So today discuss about the UGTRB, then unit 2, then thermal physics, then test number 3 some of the selected question we have to discuss today. Okay, some of the doubt section. Okay, so then question number 6, it one of the concept based question. Then atomicity of molecule carbon dioxide is, then CO2 is. So then what is mean by atomicity, then how to define? That is the number of atoms present in the molecule. If you take CO2, so then carbon, how many atoms? 1 atom. Then oxygen, 2 atoms. Upper total, so carbon 1 atom plus oxygen 2 atom. Upper 1 plus 2, 3 atoms. So in CO2 molecules, how many atoms should present? 3 atoms are present. Okay, so option C is correct. Okay, sometimes definition idhe kekkalam, then which one of the following is correct about atomicity, or 4 option kodutittu the option definition for atomicity, the number of atom present in the molecules. Okay, so next one is numerical problem. If specific heat at constant volume, then 20.8 joule per mole Kelvin, the gas is. So இங்க என்ன கொடுத்திருக்காங்க, only then specific heat of constant volume மட்டும் தான் கொடுத்திருக்காங்க. So we know that the standard value. Okay, so these are all the standard value you have to remember, or you have to memorize those values. So then standard value for monoatomic gases, that is then specific heat at constant volume CV is equal to then 3/2 R. For diatomic gases, then specific heat capacity at constant volume 5/2 R. Okay, then similar for polyatomic gases, like that. Okay, so you have to remember those two values. So most of the exams only ask either monoatomic gases or diatomic gases, and similar cases only we move on for polyatomic gases. Okay, monoatomic gases, diatomic gases irundale podum. Mostly 99% of exams only ask either monoatomic gases or diatomic gases. Okay, so here what is the R? R is the gas constant value. So what is the value, standard value? That is a constant value. R is equal to then 8.314 joule per mole Kelvin. Sometimes idhe kekkalam. Okay, sometimes there should be a constant value kekkalam. So which one of the following is right for gas constant value? Okay, then 8.314 joule per mole Kelvin. Appo here CV kuduthitaanga. Okay, appo we know that the here which one is correct, monoatomic gases or diatomic gases or polyatomic or diatomic. So we know the standard value for monoatomic gases, for diatomic gases. Okay, first we have to check out the value. அப்போ நம்மளுக்கு இதில் ஸ்பெசிஃபிக் ஹீட் கெப்பாசிட்டி அட் கான்ஸ்டன்ட் வேல்யூ நம்மளுக்கு இந்த 20.8 வரணும். ஸோ அப்போ 20.8 எதில் வரணும்னு we have to check either monoatomic or diatomic or polyatomic or diatomic. Okay, so first we have to try first one. Okay, then monoatomic gas, then CV is equal to then 3/2 into what is the value for R, then 8.314. then we have to divide 3/2, then we have to get 1.5 into 8.314, then we have to get 12.55. Okay, here அப்போ monoatomic கிடையாது. Okay, so that is wrong. So then second Then we move for diatomic. For diatomic gases, then CV is equal to, for diatomic 5 by 2. 5 by 2 into R is the gas constant value, then 8.314. Then what is the value for 5 by 2? Then we have to get 2.5 into 8.314. Then we have to multiply, then you have to get 20.8 joule per mole Kelvin. அப்போ கொடுத்துருக்க வேல்யூ என்ன 20.8. then we have to get 20.8 for diatomic gases. So option B is correct. Okay, so the diatomic gases is the correct answer for question number 8. Okay, so இதே for monatomic, இங்கே வந்து monatomic CV is equal to the value this one for 12.55 கொடுத்துருந்தாங்கன்னா the answer is monatomic. Okay, so just we have to remember those two cases, most important. Okay, so next one also one of the numerical problem. Here then specific capacity at constant pressure Cp is equal to then 29.1 joule per mole per Kelvin. Then we have to find out then specific capacity at constant volume. Okay, so we have to use the Mayer relation. Okay, so we know that the formula by using Mayer's relation. So most important, sometimes in the relation I கேட்கலாம். Okay, then Cp minus Cv is equal to R. Here Cp என்றது என்னது specific heat capacity at constant pressure, Cv என்றது then specific heat capacity at constant volume, R is the gas constant. அப்போ here which one is given, then specific capacity at constant pressure. அப்போ Cp is equal to 29.1 joule per mole Kelvin. Appo we know that the relation for Mayer's relation. Appo then Cp minus Cv is equal to R. Appo we have to find out Cv. Appo we have to rearrange this one. Appo minus நம்மளுக்கு என்ன கண்டுபிடிக்க சொல்கிறாங்க specific heat capacity at constant volume. அப்போ Cv, so Cp right hand side கொண்டு போயிட்டா then R minus Cp. அப்போ minus Cv is equal to, what is the value for gas constant? We have to given in the last question itself. Okay, what is the value for gas constant? That is 8.314 joule per mole Kelvin. Okay, so then 8.314 minus, here we have to given that specific heat capacity at constant pressure 29.1. அப்போ minus Cv is equal to just then 8.314 minus 29.1 போட்டோன்னா then we have to get minus 20.786. so then both side we have to cancel minus, then Cv is equal to then 20.786. this is the value for specific capacity at constant pressure. Which one is right? Option A is correct. So it is approximately 20.8. so option A is correct. Okay, so you have to remember this one. Okay, sometimes in the relation is straight direct question. So which of the following is Mayer's relation கொடுத்துட்டு some of the question may be given that then Cp minus Cv is equal to R, then Cp plus Cv minus R, அப்படியே reverse then Cv minus Cp, then Cv plus Cp. Okay, so the question may be like this. Okay, then you have to remember all the conditions. Okay, so next question number 16, it's one of the concept oriented. Okay, so question number 16, at very high temperature the diatomic approaches, that should be, we know the relation. What is the specific relation? Then Cp minus Cv here at high temperature, that is the important cases. So we know that when the degree of freedom is increases, then ratio is decreases. Okay, so you know the three motions. We know that the degree of freedom. So what is meant by degree of freedom? So the degree of freedom, independent wave in which the molecule can store the energy. There should be three types. One is translation motion, then rotational motion, then vibrational motion. So at a high temperature, so already we have to discuss in the last classes. Okay, then translation motion, then rotational motion, another one is vibrational motion. So then translation motion only occurred at low temperature. Okay, most important. So then rotational motion at moderate temperature. Okay, moderate temperature, that is room temperature. So then vibration motion occurred only at high temperature. அப்போ இங்கே கொடுத்துக்கிறது என்னது? That is very high temperature. அப்போ very high temperature only vibration motion occurred. அப்போ translation motion what is the degree of freedom? Translation motion what is the degree of freedom for translation motion at low temperature? 3. Okay, what is the degree of freedom for rotational motion at room temperature, that is moderated temperature? That is 5. Then vibration motion at high temperature, what is the degree of freedom? That should be a 7. Okay, these are all the three cases. So then translation motion 3, then rotational motion 5, then vibration motion then 7. So these are all degree of freedom. Okay, so in translation motion at low temperature, what is the degree of freedom? 3. Then rotational motion at moderate temperature, at room temperature, what is the degree of freedom? 5. At high temperature in vibration motion, then what is the degree of freedom? 7. Going high temperature, at high temperature obeys only vibrational motion. Appo what is the degree of freedom? 7. Appo we have to write the formula, then Cp minus Cv, then which is equal to then F plus 2 by then F. This is the one of the formula you have to remember. Okay, so important. So you have to given this relation. Okay, that is the specific heat capacity ratio, which is equal to then here what is the F here? Then F is the degree of freedom. About what is the here F? F stands for degree of freedom. So at high temperature it will be vibration motion. About vibration motion what is the degree of freedom? 7. About then gamma is equal to then 7 plus 2 divided by what is the value for F? 7. About 7. About 7 plus 2 then 9 by 7. So what is the value for 9 by 7? Then we have to get 1.29. Okay, so option C is correct. Okay, so you have to remember this one. So very important. Okay, so we have to remember those cases. Okay, so what is the degree of freedom for translation and rotation and vibration motion with respect to different temperature, low temperature, room temperature, at high temperature. Okay, so most important. Sometimes they should be asked directly. Okay, what is the degree of freedom at low temperature in translation motion? Just 3 kuduthalaam. But inge formula use panni podumbodhu then we have to put or you have to use this formula. Okay, okay. Okay, the next question also similar type. Okay, then question number 19. Here for a monatomic gases, if then specific capacity at constant volume Cv is equal to 12.5, then we have to find out the R. Already we know that the formula. So for monatomic gases, what is the standard value? For monatomic gases, what is the value? Cv is equal to, what is that? We have to already write that. What is the standard one? That is monatomic gases. Cv is equal to 3 by 2 R. So then 3 by 2 R. So in the cases we have to find out only R. Okay. We have to rearrange the term. Okay. Just we have to 3R, then we have to cross multiplying, then 2 Cv. Okay, enna pannirukanga, just we have to rearrange this equation because we have to find out only R. Then 3R is equal to, then 2 into what is the value for Cv, that is specific capacity at constant volume, already given, that is 12.5. 12.5, then 3R is equal to, then we have to multiply 2 into 12.5, then we have to get 25. Then R is equal to, then 25 divided by 3, we have to get 8.33 joule per mole Kelvin. So this is the answer from that option. A is correct. Okay, just we have to remember that. Okay, good. So next one is assertion and reasoning. So question number 22, then assertion for an ideal gas Cp minus Cv is equal to R. Then reason, then internal energy depends only on the temperature. Okay, this is also true statement. So then internal energy depends only on temperature. This is also true, but this is not correct explanation for assertion A. Okay, that is the important cases. So option B is correct, because then Cp minus Cv, there should be a then difference. That is the important. Okay, the difference between the Cp and the Cv arises at constant pressure, and part of the supply heat is to do the external work during the expansion. Okay, so but both the statement are correct, but reason is not correct explanation of A. Okay, so then option B is correct. Okay, but some of the students we have to choose option A because both the statement are correct. Okay, you have to remember that for an ideal gas Cp minus Cv is equal to R, that statement also true, but reason internal energy depends only on the temperature, those statement is also true, but we have to compare that. கொடுத்துருக்க அசஷனுக்கு ரீசன் வந்து கரெக்டானு பார்த்தீங்கன்னா கரெக்ட் கிடையாது. ஓகே, கொடுத்துருக்க அசஷனுக்கு த ரீசன் இஸ் நாட் correct explanation. Okay, then we have to choose B option. Okay, so then most of the students they pick the answer A. So A is not correct, only B is correct, but both the statement are correct, but not correct reason for assertion, given assertion. Okay, that is the important. So next one, that is concept based. In vibrational mode became active. So when the vibration mode became active? Yes, at high temperature. Okay, so already we have to discuss that. Where is that? Here. So then translation motion, low temperature, then rotational motion, moderated temperature, room temperature, then vibration motion only at high temperature. Okay, apo high temperature, vibration mode nale you have to remember only high temperature. Apo if vibration mode became active in a diatomic gases, then what is the specific heat ratio will be? Apo we have to directly we have to choose when temperature is increases, then we know the relation. Then specific heat ratio, that should be specific heat capacity at constant pressure divided by specific heat capacity at constant volume. So at high temperature la then specific heat capacity of constant volume is increases, then this one is decreases. B is correct. Okay, you have to நீங்களே போட்டு பார்க்கலாம். Okay, for initially or we have to remember those cases. Okay, so here what is asking, then specific capacity ratio. When the specific capacity at constant volume is increases, then the ratio will be decreases. Okay, we know that when vibration mode is active, then degree of freedom is increases, or you have to remember this one. So in this cases, when the vibration mode is active, this is the standard one. Okay, degree of freedom is increases. Okay, if degree of freedom is increases, then specific heat capacity at constant volume CV is also increases. If both degree of freedom and specific capacity is increases, what is the ratio? Then ratio will be decreases. Okay, then already we have to given that for those cases where that here you have to see that already we have to given everything, then translation motion and rotational motion and vibration motion. For we have to put here, then 3 plus 2 5 divided 2 putting, then we have to get this one result. And rotational motion like degree of freedom, then 5 plus 2 divided by 5 putting, then we have to get this result. Then vibration motion lab, then we have to put, already we have to put, then we have to compare these three cases, so then ratio will be decreases. Okay, I hope you have to understand those cases. So everything, question number 6, you have to get everything, every idea in that questions. Okay, so here already we have to do for very high temperature, then ratio is 1.29. then we have to put same for at high temperature, at moderate temperature the value is high, so that the reason is the specific ratio is decreases for very high temperature. Okay, so that is the reason. Okay, so the next one, question number 28, what is the atomicity of CH4? So already we know that the reason, what is meant by atomicity, that should be the number of atoms present in the molecule. Suppose CH4, then C plus, how many H are there? 4. H plus, H plus, H plus, H plus, then we have to get, so option C is correct. Okay, so the same one what we discussed in the first question, then carbon dioxide. Okay, here then CH4. Okay, so just we have to add the number of atoms should present in their molecules. Here how many of carbon atom? 1 carbon atom. So how many of hydrogen? So how many hydrogen atoms should present in CH4? 4. Here 1 carbon. Above 1 plus 4, then we have to get 5. Okay, so next, assertion and reason. So then assertion, then specific heat ratio, then Cp minus Cv. So this also true statement. Then Cp minus Cv plus R, this statement also right. For example, you have to standard, then Cp minus Cv is equal to R. Just we have to rearrange, then Cv and the pakam pochina, then Cp plus R. But both the statement are correct, but reason is not correct explanation of given assertion A. So this also wrong reason, or is not correct explanation of A. Okay, but mathematically it is correct. Okay, mathematically for the perspective, both mathematical steps are correct, but it is not correct explanation given the assertion. Okay, so we have to choose option B. Then most of the students, they pick the option A. Okay, but mathematically both the statement are correct, but according to assertion, the given reason is not correct explanation for A. Okay, you have to choose option B. Okay, so next one is another one is also numerical problem. So then specific heat capacity at constant volume கொடுத்துட்டாங்க, then 12.5, then we have to find out the specific heat capacity ratio. Okay, so we know that the Mayer's relation, by using Mayer's relation, what is the Mayer's relation? Then Cp minus Cv is equal to R. So we know that the formula, then what is the ratio? Then Cp minus Cv. So in Cv மட்டும் தான் கொடுத்துறாங்க, so then we have to find out the Cp value. So that's why we have to use Mayer's relation. அப்போ இங்கே என்ன கொடுத்துறாங்க? Cv மட்டும் தான் கொடுத்துருக்காங்க. அப்போ then Cp Cv ரைட் சைட் கொண்டு போனால் then R plus Cv. அப்போ Cp, then what is the gas constant volume value? Then 8.314 plus then specific capacity at constant volume is given, that is 12.5. so then we have to add then 8.314 plus 12.5, then we have to get 20.814. so we have to just, we know that the value for Cp, that is 20.814. so just we have to substitute in that relation, that is specific heat ratio, then Cp divided by Cv. so what is the Cp value? Then we have to find out by using Mayer's relation. then 20.814 divided, what is the Cv value given in that question? That 12.5. just we have to divide, we have to get 1.677. above from the option A is correct, 1.67. okay. So next question number 41. so then 41 is also the numerical, but it should be a simple one. okay, by using the Mayer's relation, by using Mayer's relation. so what is the Mayer's relation? Then Cp minus Cv is equal to R. okay, in these cases also we have to find out a ratio, then gamma is equal to then Cp minus Cv. okay, then Cv கொடுத்துட்டாங்க, then we have to find out the Cp value. so then minus Cv is equal to then R plus Cp, then minus Cv is equal to, what is the value for Cv here? we have to find out the value for specific heat ratio, then Cp minus, what is the given that? okay. so Cv கொடுத்துறாங்க, we have to find out Cp only. okay, then Cp is equal to then R plus, then Cv right side கொண்டு போனால் then minus will became plus. அப்போ then Cp is equal to, what is the gas constant value? then 8.314 plus what is the Cv value given in that question? then 20.8, then we have to add, then we have to get 29.1. okay, then Cp value is 29.1, then we have to find out this one. okay, so what is the Cp value? then we have to find out 29.1, then what is the Cv value? then 20.8. just we have to divide 29.1 divide 20.8, then we have to get 1.40. so which option is correct? Option B is correct. okay, so you have to remember those formula. then another one, we have to find out this formula. okay, so next one, so these are also one of the concept related. as temperature is increases, so as the temperature is increases nala enadhu, there should be a vibrational motion. but what is the vibration motion nala enadhu? degree of freedom increases, then specific heat capacity at constant volume is increases, the specific heat ratio will be decreases. அப்போ இங்கே என்ன கேட்டிருக்காங்க? then specific heat ratio for diatomic is here decreases. option B is decreases. Same question but asked in indirect. So the same question will be discussed in the previous question also, but the question will be asked in indirectly. Okay, so then concept wise you have to strong, then we have to attend all the question in the examination. Okay, so okay, if you have any doubt about this video, you have comment your question in the comment section. Okay, thank you.